We just talked through how cannabinoids like THC and then terpenes like D-limonene can actually dissolve in things like water easily. We see a little bit of our THC compounds able to be dissolved in things like ethanol, which are less polar than water. But overall, we see that they best extract out into nonpolar compounds. And so one of the questions that I had after that is, what about weed sodas? So cannabis sodas are ice cold, water's the solvent, and yet it delivers THC to the consumer. And so this is a compound that's nonpolar, and it's being consumed in a very polar solvent, so how it works is emulsions. An emulsifier is a compound that will make a liquid that's nonpolar be suspended in one that is polar. So they don't have to have similar intermolecular forces. And it's not really dissolving the compound. Instead, it's distributing it evenly as a suspension in the solvent, the water solvent. And there's a really common example that you use probably every day, soap. So here's a soap molecule. As you can see, it has this long nonpolar tail that has just carbon-carbon and carbon-hydrogen bonds. And then it has a carbon bonded to two oxygens on one end. Call this the polar head because it is polar for one. So we've got a dipole moment here. And also we have interactions with these oxygen atoms. We have ion dipole interactions and hydrogen interactions with water. It has a -1 charge on one of those oxygens that's kind of distributed over that space. And so water can line up its dipole moment with that negative charge and create a pretty strong interaction. And so this allows the soap molecule to interact with both nonpolar compounds and polar compounds. So something like grease when you're washing your dishes is nonpolar. And if we just used water, we'd have a really hard time getting it off of a surface because water is polar and they don't dissolve each other. But if we use these soap molecules, the nonpolar ends of the soap molecules will interact with the nonpolar grease, and the polar end of the soap molecule will interact with the polar water, allowing the grease then to be washed away by the water. And now it does this by forming these things called micelles. So a micelle is going to be a number of soap molecules where all the nonpolar ends are going to point in towards each other and interact with one another. And then all of the polar parts of the molecule will be on the outside of this micelle, which is a sphere. And they'll interact with the water, and that micelle will essentially seem soluble in water, but it's a pretty large particle. And so it's hard to think of it as just an individual molecule dissolved. It's like a particle suspended in the water. And so when this micelle with this interior that's nonpolar and exterior that's polar comes across a nonpolar compound, it can dissolve the nonpolar compound into the middle of the micelle. And then the outside is still interacting with water, and it can then suspend that nonpolar compound in the polar solvent. And so that's how soap will remove grease from a surface, but it's also how we can suspend THC into water in a soda or a beer or some sort of beverage. And so we are seeing nano emulsifiers used to create these cannabis beverages. A nano emulsifier is going to make sure that this micelle particle can only be about 20 to 200 nanometers in size. And that's so tiny. A nanometer is 10 to the -9th meters. It's really, really, really itty bitty. And so these really, really itty bitty particles will be suspended in the water evenly and evenly distributed rather than sinking and collecting to the bottom of the bottle. And so this is how, even though THC is not going to be soluble in water, we can use another molecule to evenly distribute it through it and deliver the THC to whoever's consuming the liquid.